next type of segmentation is used by command named imseg-geodesic. So from the name you can able to understand that we are doing segmentation using based on the geodesic distance. So let's see what's meant by geodesic. So in graph theory subject, so geodesic distance is nothing but the distance between the geodesic is the shortest path between the two edges. So we shall check for the program now. Okay, so it's already been copied there. Okay, so by this time you would have understand that almost all the segmentation they are creating a mask, and based on the mask they are doing the segmentation. So here initially they are reading the image named yellowlily.jpg format and displaying that. Then we have to create the mask based on the region of interest. So here there are two things are there, object and the background. So initially they are creating a region of interest, is nothing but ROI. Then based on that they are creating a mask. So object and the background. So finally we are applying the segmentation on the input image based on the object and the mask background. Then we are converting the binary image into color image. So we are doing the labeling operation there. So labels are nothing but the similar category objects are considered as are assigned some names. So this is the input image, yellow lily. Okay, so I will write the figure comma I am show so that you can able to understand the process easily. So this is the input image. Okay, figure 1 is the input image, and in that we are creating the two ROIs. So one ROI for the object and the other ROI for the background, and this is a label to RGB. So this is the label to RGB. See, for that figure 2 we are highlighting we are giving the label to the object alone here, and at last we are applying this object to the over the input image. So finally you can see our intended object. See, our idea is to display this particular object alone. So that's why we are doing the segmentation, and finally this object alone will appear in normal color, and the remaining entire background will be given another type of labels. So this is called geodesic segmentation. So in this output you can see there are two regions we have divided. So one is entire background and second one the object. Now we are going to see three regions using the same algorithm. So the same image we are going to see the three channels. We are going to divide into three regions. Okay, so for all the images to be displayed I will type the figure comma so that you can able to understand the process between. Okay, so I am executing this program. Figure 1 is nothing but the input image, the yellow lily, and figure 2. Okay, we shall see one by one. So figure 1 is the input image. So in the previous example we have discussed about two regions. So we have created two region of interest. Now in this input image we we have to, our objective is to create three type of regions. So we have to declare three region of interest: the object, background, and another complete different background. So figure 1 is completed. Figure 2, now you can see, compare this one, this. So our object is displayed here. The another region, the background region, is divided into two categories. So one which has the stem, leaves and all, and another which has the sands. And this is the thing to differentiate all these three labeling characters. So here we are just identifying the labels to each values. Here finally you can see these are the, this is the exact object, and the top portion is nothing but the flower part. So we will see that code. As I told already, we have to create three region of interest and obviously three mask. Then we have to apply our command or the input image based on the tree mask. Then we have obtained the segmented image. So after obtaining the segment image, we are getting the other refined segmented image. Finally, when you apply the geodesic command again. Okay, so since we have not mentioned the figure command here, the last refined segmented image is not appearing. So I have added the figure word before montage also, so that you can see the refined segmentation output. Okay. Okay, here there is no much difference, but what happens means it exactly pinpoints the region perfectly. So it is going refining the output. See here you can see that blue label is visible, but here it is not clearly visible, and the border has to end here. These are unwanted extra things, so it is perfectly segmented here. So the output is refined further after creating the fourth mask, that is called the refined segmented image. And then next one, IMSegFM. So here we are going to do segmentation of the image using fast marching method. So I am going to explain this with respect to the cameraman image. So cameraman image, which is more popular, and you can be able to visualize it very easily. I am executing this. So there we are getting three images. First the input image, and the second segmented image. Third one, just we are calculating the geodesic distances. So here the expression of code is, we are creating a mask. So for creating a mask, initially we should initiate it with a 0. Then for that particular object alone, we have to declare it as 1. So here the particular object of the mask, we are declaring it as true. So true and 1 both are same. Instead of zeros, we have mentioned as false, both are same. Then they are finding the weights of each points. Then they have calculated the threshold. Then based upon this algorithm, we are doing the segmentation. And at last we have displayed the geodesic distances. So now in this slide we have seen two types of segmentation: IMSeg geodesic, and another one fast segmentation, fast marching method. Both are based on geodesic distances.